An accelerometer is a sensor that measures the physical acceleration experienced by an object due to inertial forces or mechanical excitation. In aerospace applications, for example, accelerometers are often used along with gyroscopes for navigation guidance and flight control. Conceptually, an accelerometer behaves as a damped mass on a spring system. When an accelerometer experiences acceleration, the displacement of the mass is measured in order to obtain the acceleration value. In these devices, piezoelectric, piezoresistive, and capacitive techniques are commonly used to convert the mechanical strains into electrical signals. Piezoelectric accelerometers rely on piezoceramics or single crystals such as the quartz or tourmaline. They can be classified into charge output type or the voltage output type. Well, for piezoresistive accelerometers, they are preferred in high shock applications such as the automotive crash test. Also, capacitive accelerometers performance is superior in low frequency range, and they can be operated in several modes to achieve high stability and linearity. In piezoelectric type accelerometers, the voltage output type, one of the most preferred type of it is the IEPE piezoelectric sensors. The IEP stands for the Integrated Electronic Piezoelectric. Right, so this is the most preferred type in the industry because they have the fixed sensitivity regardless of cable length and their quality. And with low impedance output, they can be transmitted over long cables in harsh environments with inexpensive signal conditioners and cables, broad bandwidth, but they are inapplicable where the ambient temperature exceeds the capability of the built-in circuitry, which is usually less than 125 degrees Celsius. The three types of piezoelectric accelerometers identified in the ASI VR lab are the uniaxial accelerometer, the triaxial accelerometer, and the miniaturized accelerometer. The prefix piezo is Greek for press or squeeze. As the name implies, an electrical potential is produced when the piezoelectric element is squeezed. The electrical potential is then being transported to an instrumentation system for processing and to be analyzed.
The automatic step detection in accelerometer signal provide useful information in many ways. So, how the signal is analyzed? When accelerometer detects signal, it needs filter for smoothing the data. For example, it's like this. The accelerometer from mobile phones are extremely noisy, so it very needs to have filter. As it will filtrate, we use integration to convert it into velocity and displacement. Integration. Integration is the output result from the proceeding operation exhibit multiple peaks and hence need to be smooth. It is moved through a moving window integration filtering, where N is chosen to be 20 empirically. Each step cycle yields double peaks with motoric acid and descent. Then use FFT to produce some interesting results. One of my attempts was to FFT the acceleration signal, then render low frequencies to have absolute FFT values of 0. Then I use omega arithmetic and inverse FFT to gain a lot for velocity. The result were as follows. Use a low-pass filter on original acceleration data, which can do a great job of smoothing it. Thank you.
Assalamualaikum. My my name is Lazim. Now I would like to explain about the sensitivity of the sensor. We know that sensitivity is the gain of sensor ability and can be determined in various ways. And so, sensitivity is actually the ratio of change in acceleration to change in output signal. That means the input acceleration is directly dependent to the output signal. And so we got in accelerometer the specified particular supply voltage and expressed in units millivolt per gram for analog output accelerometers. And the sensitivity is also ratiometric, that means towards the supply voltage, double the supply voltage means double the sensitivity of the sensor. Okay, how the sensitivity is work. And so I could explain that when we apply the 1 gram of acceleration to it, the sensor can measure direct current acceleration, and by pointing the axis towards the center of the earth, noting the output value, and rotates the sensor 180 degrees, and then noting the output value again. And then by doing so, the 1 gram of acceleration is applied to the sensor, and hence we could get sensitivity.
Graph to show the sensitivity of the accelerometer. Please remind that this graph is not the actual performance of the sensitivity, but to give a picture of how it works. Kindly note that the output level will be proportional to amplitude of vibrations.
This is the example of the accelerometer. This is the piezoelectric accelerometer. There is a sensor inside, which calculates the sensitivity of the sensor. And usually we know that the accelerometer sensitivity counts in 10 millivolt or 100 millivolt per gram. And we know that the sensitivity in accelerometer can also be related with nonlinearity, a type of measurement of the deviation of an accelerometer response. And ideally, the relationship between voltage and acceleration is linear and described by the sensitivity of the sensor. There are various types of accelerometer in this lab, but we only take 3 of accelerometer available in this sensor in this case. And the 3 types is the 1-axis accelerometer, which is it measure in 1 axis only. And then we have the triaxial accelerometer that calculates and measure the sensitivity in 3 different axes: the x-axis, the y-axis, and the z-axis. And then we got the piezoelectric 100 millivolt sensor millivolt.
The variety of accelerometer used result from different applications with requirement of range, natural frequency, and damping. Various accelerometers with their special characteristics are reviewed. The basic difference is the method of mass displacement measurement. In general, the specification sheet for an accelerometer will give the natural frequency, damping coefficient, and scale factor that relates the output to an acceleration input. The values of test and spring constant are seldom known or required.
This is the piezoelectric sensor. In the vibration lab, it is being used in the torsional vibration experiment. The accelerometer are attached to the vibrating or oscillating mass. As we know that piezoelectric sensor will produce voltage when stress are applied to the sensor. The voltage signal will be collected by the data acquisition hardware. Next, the software from the PC will convert the data into acceleration. We can convert the acceleration value into velocity and displacement according to our need. Usually, in torsional vibration experiment, we want the reading of the displacement of the oscillating mass. LVDT are not suitable for this experiment because LVDT function in linear motion. This experiment involves angular displacement. Thus, piezoelectric sensors are used because it can easily be attached to the mass. Then, the acceleration data will be converted into displacement using the ZLab software. Other information such as decay rate, stiffness, and frequency can be determined using appropriate formula and the data obtained by the accelerometer.
Accelerometers are also used in the vibration absorber apparatus experiment. This type of accelerometer can easily be attached to the beam with a metallic material. The purpose of the experiment is to find the stiffness of the beam. When the disc is rotating, it will produce a linear vibration motion. The accelerometer will detect the change in the displacement of the beam. The accelerometer again will produce voltage signal which will collected by the computer and convert into acceleration by the DaisyLab software. Thus, we can obtain the natural frequency, stiffness, damping and decay rate. Another experiment involving the accelerometer are the spring mass system experiment. The accelerometers are attached to the mass to determine the change in the displacement of the mass. The data collected by the accelerometer are acceleration and need to be converted into displacement. The displacement can be obtained from the computer in the DaisyLab software. From the displacement of the mass, we can obtain the change in elongation of the spring and the reading can be used to determine the stiffness, the decay rate, damping and natural frequency of the system.
Next, we move to the final question, which is describe another application of a sensor in the industry. Okay, before I go to the what the uses of industry, I will explain about what is the accelerometer used in the engineering. Okay, first, the accelerometer is used to measure the vibration on cars, machines, building and safety installation. Besides that, used also to measure the vehicle acceleration to evaluate of overall vehicle performance and response. Okay, in our lab, vibration lab, there's three accelerometer used to measure in engineering field, which is 2 degree of freedom automobile, torsion vibration and force vibration. Okay, next I will explain more about what are the use of accelerometer sensor in industry. Okay, in industry, accelerometer are used widely in machinery, in factory basically. So the accelerometer used for machinery help to report the vibration and changes in time of shaft at the bearing of rotating equipment such as turbine, pump, fans, compressor and cooling tower. So from the accelerometer, they convert to vibration monitor program. At the vibration monitor program, they warn of impending failure, save money, improve safety in plants by detecting conditions such as wear, tear of bearing, shaft misaligned, rotor imbalance, gear failure, and bearing pop, which can lead to costly repair. So from the vibration monitoring program, the accelerometer vibration data allows the user to monitor machines and detect fault before rotating the fails. For example, in factory, they testing the machine first before they use for produce the product to avoid costly repair and loss of product. Other than that, this sensor is used for automobile manufacturing, machine tool application, pharmaceutical production, power generation and power plants, sugar mills, food and beverage production, water and wastewater, hydropower, petrochemical and steel manufacturing. That's all for me. Thank you.